Hello and welcome to another video about making stuff look good in Unity. Today the topic is going to be shaders. This is a massive subject, so we're only going to scratch the surface in this video. But this is a topic I see people requesting tutorials and resources on all the time. Now I got a note about my last video that I should watch my language, and I agree with that, so I'm going to avoid using words like shit and fuck this time. Cool? Cool. Let's get started. So here we have 4 basic quads, each with a different shader applied to them. I'm working in a 2D perspective here because that's the dimension I typically work in, but a lot of what I talk about is going to be relevant in 3D as well, especially if you get into image effects down the road. Now I'm going to simplify the rendering process quite a bit here because the goal today is to get you authoring cool shaders as fast as possible without regurgitating everything I've ever learned in books in school about graphics. Traditionally in graphics programming, you'll have 2 small programs called the Vertex shader and the fragment shader. The Vertex shader takes data from the mesh and manipulates it in some way and passes along fragments to the fragment shader. 3 vertices make up a triangle and could generate a couple hundred fragments based on how much of the screen that triangle occupies. And a fragment is like a potential pixel. It can be manipulated or discarded, all before it becomes a concrete colored pixel on the screen. There's a lot more we could say about this process, but again, we're just scratching the surface today, so let's see how this stuff applies to Unity. Here's the shader code for the plain white quad. There's a lot of code here just to produce white pixels, so we're going to go over what all this does just to achieve like the most boring shader imaginable. There are 4 key parts of this shader. We've got a struct called appData. It defines what information we are getting from each vertex on the mesh. Then we've got a struct called v2f. It defines what information we're passing into the fragment function. Next we've got a function called vert. It takes our appData struct as a parameter and returns a v2f. And finally we have a function called frag. It takes our v2f struct and returns a color in the form of a float4 variable. So let's see what the vert function is doing. All it looks at on the mesh is the position of the vertex. That's typically going to be like a vector 3. In the mesh's local coordinate system. All this vert function does is initialize a v2f called O, and it sets its vertex variable using this special function. I'm gonna keep this short and gloss over complicated, less important stuff, so all I'll say about this function is that it does an operation called matrix multiplication on that local vertex to take it from a point relative to the object and transform it into a point on the screen. And that's it for the super simple vert function. Now onto the frag function. Like the fragment shader I mentioned earlier, it turns potential pixels into colors on the screen. We don't get to change the position that was already locked in by the vertex function. Instead, we just get to return a color at that given position. For this super simple basic frag function, we just return the color white, where the 4 numbers are red, green, blue, and alpha respectively. And that's how you get white pixels on the screen. It seems like a lot of work, but believe me, Unity is doing a lot of the heavy lifting for us. But with all this boring stuff sorted, we can start messing around with the shader and get something more interesting on the screen. So in that image from before, I showed the fragment shader turning the pixels orange. We can edit our basic fragment shader to do just the same thing. Where we plugged in 4 ones into a float4 earlier, we can just put in some new numbers that result in a nice shade of orange. And ta-da, we have orange pixels. But just returning the same color for every pixel is still pretty boring, so let's bring in some more data from the mesh and do something more interesting. We'll add a field to the appData struct called UV of type float2 and add the textQuard0 identifier. A quick note, which data you can grab from the mesh are limited to a short list of values, so I'll put a link to the Unity docs in the description with more info on providing data to vert functions. We'll do the same thing with our v2f, so we can pass along UV data to the individual pixels. Now let's change up the vert function. There's no Unity magic functions this time. We're just going to pass along the UV as is to our frag function. Once that's done, we can change up our frag function. We'll base our color off the values we got from the UV and return that. Bam. But Dan, you ask? A triangle has but 3 vertices. If our vertex shader only executes 3 times, how on earth are we getting such a splendid display of colors? That's a good question, vaguely British Unity developer. You remember when I said that even though a vert shader only runs 3 times, it can still generate hundreds of fragments? Well, it also linearly interpolates its values over those generated fragments. So even though our vert shader really only passes along 4 unique UV values, we end up getting every value in between. Okay, now we're done with that tangent. We're like 5 minutes in, so how about a little break? For me, I mean. While I'm on break, see if you can get the quad to look like this. Remember, we fed in the X and Y values of the UV into the red and green parts of the color, but we left the blue at 0. Welcome back! Did you get it? All you had to do was set the blue value to 1 in our float 4. It wasn't really tricky or anything, but I figured you might want to experiment or whatever anyway, so moving on. So at this point, you know how to color some pixels using some data from the mesh. Let's take a look at how to texture the quad. I'm using a small texture of Pusheen the cat. It's got transparency, which is what's causing those crazy lines around the sprite. You can use whatever texture you want, but later on you're going to want one with some transparency in it, so just grab a sprite from a game or something. Now back in shader land, we're going to define a set of properties for our shader before the subshader region. This is the syntax for including a texture as a property and a default value of white for when no texture is assigned. As soon as you've done that, the texture picker will appear in the inspector when you select the material in the editor. In our frag function, we'll use the text2d function to get the color value from the main text at the provided UV value. We also need to define main text in the scope of our CG program as a sampler 2D, otherwise our shader won't compile. And with that, we should have a textured quad. It's not too shabby, but this is supposed to look like a sprite, you know, with transparency around the edges and not these ugly lines. So now we'll fix that. The way to have transparency in your shader is to define how each pixel will blend with the pixel beneath it on the screen. There's a finite number of these blend modes, and so again, I'll point you to the Unity docs where you can learn more about them. For our purposes, we'll be using what's referred to as an alpha blend, and it looks like this. What this means is we take the source color and multiply it by the source alpha, and we add that to the destination color multiplied by 1 minus the source alpha. You can take a second and think about why that makes sense, and hopefully whatever visuals I give this part of the video aid your understanding of how alpha blending works. The other thing you'll need to do is define the Q tag as transparent. This just makes our sprites render after the opaque geometry in the scene, along with all the other transparent stuff. If you skipped this step, you'll find weird rendering quirks whenever you have your custom shader overlapping with opaque geometry. And that's alpha blending in 60 seconds. We should now have a textured quad alpha blending over top of the scene. It's taken us a while to get here because I've taken a bunch of detours from here to there, but I hope it feels like it was somewhat worth it. Once you get a handle on this stuff, you'll start being able to experiment with shaders on your own and make some really unique looking effects. Here are a couple ideas you can try to reinforce your shader knowledge. Add a color property and multiply the texture color by that for a tinting effect. Use the UVs as colors like we did way before, but this time multiply that by the texture color instead. Add a second texture and a range slider, then have your fragment shader interpolate the two values while you move the range slider. Make sure your texture is set to repeat and then multiply the UV value by 2 to get tiled sprites. Combine the tiling thing and the UV coloring thing at the same time to make like an Andy Warhol looking painting. Use this equation for luminance and calculate an accurate value you can plug into all 3 of the red, green, and blue values to get a grayscale sprite. Combine the grayscale sprite with the color tinting from earlier. Change the blend mode to blend 1-1 and see what happens. Okay, that does it for this video. Shaders are a bottomless pit. There's always going to be more to learn. If you knew nothing about the world of shaders before this, hopefully you now have a good idea of what they are and how you might go about creating and editing them. I'll include the code for the 4 basic shaders and the 8 exercises below. I kind of like making these videos, so I'll probably do more later on, and we'll explore more shadery goodness. Leave your comments if you have questions, want to show off a shader you came up with, or if you just want to suggest a topic for a future video. Thanks for watching.